Hey guys, welcome to lesson 2-6. This time I'm up at the upper falls for DeSoto Falls. Today we're going to take a look at graphing equations today. We're going to look at how to put lines that we've been solving and put them on the coordinate plane, and look at how we can go about taking a graphic approach to these problems. Alright, let's get started.
Alright, so jumping into our notes, equations can be graphed on the coordinate plane. If you remember from your vocabulary notes, our coordinate plane is comprised of two axes, the x-axis and the y-axis. Now our x-axis is going to run from left to right. It's going to run horizontally. Our y-axis is going to run up and down or vertically. So looking at this graph, this would be your x-axis. This would be your y-axis. Now, we use a graph to show all possible solutions for an equation that has two variables. When you have an equation that has two variables, there can be an endless possibility of different solutions that would make your equation true. Now, it would be tough to write out every single one. In fact, it would be almost impossible. So what we do is we draw this line, and what that line represents is every possible solution that would make an equation true. So when you look at the line, if you went to any point on that line, whatever ordered pair you picked from that line would make your equation true. Now, let's go ahead and look at an example because that's really the best way to learn graphing. Now, if you look at example 1, we have the equation y equals 2/3 x plus 4. Now this equation is written in a very specific and a very special form. The name of this form is going to be slope-intercept form. Now we have a general form for slope-intercept form, and that is going to look like y equals mx plus b. So y equals mx plus b is just a general form. I just want to let you see how it matches up with this form. We have y equals, alright, m will always be some sort of number, and then you'll have x, and then you'll have plus your b. Alright, so in this equation, your 2/3 would be your m, and your 4 would be your b. Now let's look at what that m and the b actually represent. M is going to represent the slope of the line. If you remember back to your vocabulary, slope is the difference in the y values divided by the difference in the x values. If you are thinking in your middle school math, you probably heard it referred to most commonly as rise over run. B is going to represent the y-intercept of the line. Now, a y-intercept is not a word that we've defined in our glossary this time. But what a y-intercept is, if you remember from middle school, is where a line crosses the y-axis. Now, just a reminder, the y-axis is the one that goes straight up and down. Now, since the y-axis goes straight up and down here, your x value for a y-intercept will always be 0. For it to be able to cross the y-axis, which is this line here, your x value is always going to be 0. Notice every single place here we didn't go left or right at all. Our x value is 0. Now, in our example, y equals 2/3 plus x, you can see that the y-intercept, the b, is going to match up and be 4. Now, one thing to note, and I'm sorry I just moved that whole thing for you there. Let me move it back in place. But one thing to note, pay attention to this sign right here. If that were to be a negative, your y-intercept would be negative, so it would be somewhere down here. If it was a minus 4, our y-intercept would be negative 4, so it would be down here. If it's positive, it's going to be up in the top half. Now, since our y-intercept is 4, and for a y-intercept our x value will always be 0, what we did is we went to the point 0, and we went up 1, 2, 3, 4, and we drew our dot right there. That's going to be our starting point. the rest of our line is going to grow from that point right there. So it's important that we get that y-intercept right. Now, just a side note before we move on, if you had a situation that looked like this, y equals x, notice there, or let's be even more general. All right, just for a second, let's look at another case that you might run into, just so we can go ahead and clarify any mistake. All right, just for a minute, let's step aside from this example. This is just a little side example. But let's say that you run into the scenario where you have something like this, y equals 3x. All right, now notice you don't have a b here. This is just in the form y equals mx. But to be in y-intercept, we still need that plus b. Now, what would we be able to add here that would not change this at all? If you said 0, you're absolutely right. If we added a 0, remember with your additive identity from Unit 1, if you add 0 to something, it's not going to change what you start with. So 3x plus 0 is still going to be 3x, but now we have something in that b slot that we can fill in. So in this case, your y-intercept would be 0. Alright, just wanted to point that out because you'll probably see something like that in the practice or on your mastery check, just a hint that you'll want to know if you don't have a b, how do you find what your b is. Let's go ahead and go back to our problem. So just to recap that problem, our y-intercept in this particular problem was 4. So we put our dot at 0, 4. Alright, now, the next thing we have to do is to take into consideration the slope of the line. The slope tells us how our graph is going to change. It's going to tell us whether it's going to go up, whether it's going to go down, and how fast or slow it's going to go down. Now, another name for the slope is the rate of change. We talked about that in the vocabulary video. Now, slope can be interpreted as the difference in rise, or the y values, divided by the difference in run, the x values. In our example, y equals 2/3 x plus 4, our slope is 2/3. And I shifted everything there. Let me shift it back. All right. Just to recap our formula, remember, our slope-intercept is y equals mx plus b. We said m was slope, so that's how we get the 2/3 as our slope here. Now, the numerator, or the top number of the fraction, tells us how much we are supposed to go up or down. Now, if that number is positive, we are going to go, and I'm sorry, I keep moving that, we are going to go up. If it is negative, we are going to go down. Now, if we look, our 2/3, our numerator 2 is positive, so we are going to go up 2. So I go to my original point. Remember, our original point was 0, 4. And I'm going to count up 1 space, 2 spaces. So really, I'm counting up. I'm just going to draw a dashed line to represent that. I count up 2 spaces. Now, our denominator, or our bottom number, tells us whether to go left or right. If the bottom number is positive, we move to the right. If it's negative, we move to the left. In this case, it is a positive 3. So now, after I've gone up 2 from my numerator, I'm going to count across and go over 1, 2, 3. And I'm going to put my new point right there. So now I have 2 points. I could keep going and go up 2 and over 3, but realize that we have run out of our graph. So what you can do is you can reverse it completely. Instead of going up and to the right, we can go left and down. So we could go down 2 and left 3 and put another dot there. Down 2 and left 3 and have another point there. So as long as you reverse both of them, you can work the other way around. Now I just noticed that I didn't click down here just so you can get that blank filled in. In our case, we went right 3 because our denominator was a positive 3. Alright, so now we've started getting some points. We're starting to see something that's resembling a line. let's go ahead on to the next slide and see if we can complete this line. Alright, just want to talk about slope real quick before we move on. A line that has a positive slope looks like it is going uphill when viewed from left to right. A line that has a negative slope looks like it's going downhill. A line with a slope of 0 makes a horizontal line, and just a reminder, horizontal goes like the horizon. It goes across like that. Now a vertical line is said to have an undefined slope. A vertical line goes up and down like this. Now you can use Mr. Slope Guy to help you remember these facts. So if it is positive, alright, we're going to be going uphill. If it is negative, we're going to go downhill. Alright? If we have a slope of 0, it's going to be a line that looks like this. If we have an undefined slope, it is going to be a line that is straight up and down. Alright? Just a little side note here, the reason that this is called undefined, remember this is our difference in rise over difference in run. Notice with your rise, you're going to be going up a certain number of points. Let's just say, for example, that you're going up 3. Now, if you look at this line, we don't go left and right at all. So we have a change in our run of 0. So that would give us a number that looked like this, 3 over 0, because we don't go left and right. Now, one of the cardinal sins of math is dividing by 0. We can't divide by 0. If you type that into calculator, you're going to get divide by 0 error or a syntax error, depending on what brand it is. So because we cannot divide by 0, that is why that slope is called undefined. Alright, so Mr. Slope Guy is going to be a good friend of you over the next couple units to help you remember what your slope should look like. So make sure you make a note to come back and visit him from time to time and say hello. Alright, returning to our example, the last step to graphing is to connect the dots. So just to review, we had our y-intercept here. We had our point that was 0, 4. Alright, I'll just jot down our equation to the side here real quick so we remember. Our y-intercept came from the 4 there. Our slope was 2/3, so that meant we had to count up 1, 2, and over 1, 2, 3. We ran out of space, so we couldn't keep going up that way, so we had to reverse. Instead of going up 2 and right 3, we had to go down 2 and left 3 and put a point. Sorry, guys. And now we can cap this off by finally drawing in our line that connects these points. Please use rulers to draw these straight lines, especially when we get into the next unit. If you're not drawing your line straight, it's going to really mess you up. Ms. Blaylock and I both have rulers available for you. Ms. Smith should also have rulers available for you. If you don't see them lying around the room, just ask us and we'll find them. We definitely want you guys having a straight line to draw here, because it's going to be very important when we get to systems of equations and being able to tell where things cross. So please use a ruler. Yes, it's a little tedious, but it will make it look really pretty on your practice and your mastery checks. Alright, let's look at one more example. Sometimes you might be given an equation that is not put into slope-intercept form. For example, we have this problem here, 3x plus 4y equals 8. To be able to graph an equation that's given to you in a form other than slope-intercept, we have to go back to that last lesson that we did on literal equations. That's kind of the reason we put it right before this lesson. But we're going to need to use those literal equation skills to be able to solve for y here. So basically, we're going to treat this like one of those literal equations that you were working on in the last lesson and that you've shown mastery of if you're at this point. And we're going to treat that as a literal equation that we're solving for y, and that will let us put the equation in slope-intercept form. So I'm going to get myself a little bit more room to work with. So we have the equation 3x plus 4y is equal to 8. Now, to be in slope-intercept form, we always have to have the y by itself. So in our literal equation, That's what we are solving for. So I need to move this 3x over to the other side. So to do that, I'm going to subtract 3x from both sides. So I'm going to have 4y is equal to, now, this is an 8, this is a negative 3x. They are not like terms because the 3 has an x attached to it, the 8 does not. So I'm going to go ahead, to be consistent with my form of y equals mx plus b, I'm going to put my one with the x first, so negative 3x, and then I'm going to put plus 8. I do not want to combine those because they are not like terms. I want to leave them as is. Now I'm still multiplying the y by 4. So to be able to undo that multiplication, I use the inverse, which is division. Alright, now I've divided this side by 4. I also have to divide everything on this side by 4. So this will cancel out and we'll get y. And we're going to have y equals, now, a negative 3 over 4 is not going to simplify easily. Alright, we don't want to change it to a decimal though, because we're going to be needing those numerators and denominators to help us with the slope. So we're just going to leave it as negative 3/4. Yes, that is the same thing as negative 0.75, but negative 0.75 is not going to help us when we get over here to graph. Now, 8 plus 4 does simplify. 8 divided by 4 is going to be 2. So now we have y equals negative 3/4 x plus 2. Notice this is now in slope-intercept form. If I write my general slope-intercept form underneath it, y equals mx plus b, I can see that m is going to be negative 3/4 and that b is going to be 2. So now, remembering our rules for graphing that we just learned, I'm going to start with my y-intercept, which is 2. So I'm going to go on my y-axis and I'm going to put a dot at y equals 2. Now my slope is negative 3 over positive 4. Now, this can be a little bit tricky. We can either assign the negative to the top number or we can assign the negative to the denominator. Either one. What we don't want to do is take the one negative sign and put it on both and make it negative 3 over negative 4, because that gives us an extra negative that we don't want. Now I'll just demonstrate how this would be the same thing here in just a second. The top number tells us to go up or down. So since my top number is a negative 3, I'm going to go down 1, 2, 3. And I'm going to go to the right 4. 1, 2, 3, 4. Alright, I don't have room to do another space, so I'm going to go up 3, 1, 2, 3, and left 4, 1, 2, 3, 4. Now, if you notice, that's exactly what we would have done if we would have put the negative sign in the denominator. So that helps us see why we can switch them and go the other way around. You just want to make sure you only put that negative with one and that you don't put the negative with both. Other words, you're going to end up with a completely different line. Alright, our last step, we get to play connect the dots. Use your ruler. Help yourself draw a straight line. And I'm going to play the connect the dot line the best I can. I might need to move mine around a little bit since I can't have a ruler on this. But that looks pretty good. Alright. So, we have our line graphed. Remember, that represents all the possible solutions for this line. Any point that we plug in from this line will make that statement true. Alright, that wraps up our lesson on graphing. We do want you to go ahead and do all the practice on this. There were only 12 practice problems for graphing, and this is a pretty important skill that we'll build in not only on this chapter or unit, but we'll also be building on in the next unit. So we want to make sure we got plenty of practice and that we're all having a solid foundation on graphing. So we do want you to go ahead and do all the practice on this lesson. As always, let us know if we can do anything to help you out. Good luck, and we'll see you in the next video.